Now let's look at the formal definition of inverse sine, and then we'll work a few problems using inverse sine. The inverse sine function, which is denoted in this way, it's also known as the arc sine, is defined to be the inverse of the restricted sine function, where the sine is only looked at from negative pi over 2 to pi over 2. So in other words, y is equal to inverse sine of x is the number, it's the angle that's in the interval from negative pi over 2 to pi over 2 whose sine was equal to x. So keep in mind that when you have f inverse of f of x, you get x. So let's use sine instead of the f's. That means if I have sine of the inverse sine of x, I'm going to get x, as long as my x that I put in here was between negative 1 and 1. At the same time, if I've got the inverse sine of the sine of x, then I'm going to get x, as long as my x that I put into this sine function was between negative pi over 2 to pi over 2. So these two properties are known as the cancellation property because they cancel each other out. And here's a graph with the domain and range of the inverse sine. Keep in mind, please, that this inverse sine of x does not mean 1 over sine of x. 1 over sine of x is the cosecant, not the inverse sine. This means the angle whose sine is x. That's what this means, the angle whose sine is x. Okay, so if we are trying to find each value, and we want the inverse sine of the square root of 2 over 2. And so basically, we're wanting to know what angle gave me the square root of 2 over 2 when I took this sine. Now keep in mind our angle needs to come in the range of negative pi over 2 to pi over 2. It needs to be inside there. So when we look at where negative pi over 2 to pi over 2, from here to here, that's going to be, it's from quadrant 1 or quadrant 4. If it's giving me a positive sign, sine is my y value, that means I must be up here in quadrant 1. So I'm in quadrant 1, trying to find what angle gave me the sine of square root of 2 over 2. Well, the sine, where my y value is square root of 2 over 2, is going to be at pi over 4. So that's going to equal pi over 4, 45 degrees, either one, both one and the same. All right, let's look at this next problem. On the next one, we want to know what angle gave me a sine of negative square root of 3 over 2. And so now, since we're after a negative value for our sine, then we must have come from quadrant 4. Because again, our value has to come from somewhere in negative pi over 2 to pi over 2. We have to pick an angle in that region that is going to give us a sine of negative square root of 3 over 2. It had to come from quadrant 4. And so where is the sign down here that gives us negative square root of 3 over 2? Well, that's going to be down here at negative pi over 3. Negative pi over 3, and in fact we can write that out as our work. This is since we get negative pi over 3 since the sine of negative pi over 3 gives us negative square root of 3 over 2. And we could have done the same thing up here. We could have said that this is the case. This is how you can show your work like this, or you can show your work like this. Since the sine of pi over 4 equals square root of 2 over 2. Either one of those ways of showing your work is fine. How about, what's the angle that gives us a sine of 5 halves, which is otherwise known as 2.5. What's the angle that gives us a sine of 5 halves? Well, let's look back over here. So sine is our y value. We're only going up as high as 1 on the y value and as far down as negative 1. Sine is between negative 1 and 1. Sine never goes up to 2.5. And so this is going to be undefined. It does not exist. There is no angle that gives us 2.5 for the sine. So this is undefined. Since the domain is going to be between negative 1 and 1. We are not allowed to put in 2.5. Okay? All right, so let's look at number 2, example 2, sometimes these problems, the first two we were able to work up there just using what we know about our unit circle. But we're not always able to do that. Sometimes we're going to need to use a calculator to be able to figure out what the angle was that gave us that sign. And so let's make sure that we know how to use our calculator for that. And so first of all, we need to make sure that our calculator is set to the right thing. Now mine tells me that right now I've got it in radian. If I didn't have it in radian, if I had had it in degree, then right now it's in degree, then I could just come into mode, go down to the third line, make sure we highlight radian, and then quit. Second in mode gets me back out of there. Now I'm in radian. So make sure you're in the right mode when you're working these problems. So we want to know what's the inverse sine on my TI-84 here. I'm going to hit second and sine. That's got sine -1. That's my inverse sine. 0.32. And then I enter, and that tells me it's 0.325729, etc., etc. So if I was trying to get this to say 5 decimal places, then I would want to go out as far as the 2 and look at the next digit, the 9, and decide whether I'm going to go up or stay where I am. The 9's big enough that I need to go up. It's greater than 5. So this is approximately, I do the squiggly equals because this is not exactly equal to, it is approximately 32573. We can check our answer and see if it works out by putting in the sign. What is the sign of 0.325, and we said it was 73, so let's put it in that way, and we get 0.3200000, and that's because we were putting in an approximate answer that it doesn't work out to be exact, but that's the one that's going to work. Okay, so now let's look with 5 degrees of accuracy, or 5 decimals of accuracy. Now let's figure out what is the inverse sine of 1/4. So we're going to use our calculator, and we're going to say, okay, we want the inverse sine, the angle whose sine gave me 1/4, and that's going to be 0.252680. That 0 in the 6th spot is not going to make my 8 get bigger. So we're just going to put that's approximately 0.25268. And that would be my answer on that one. Alright, so what if, in example 3, I'm supposed to find the sine, I'm supposed to find this value. I've got the inverse sine of the sine of pi over 6. So now I need to make sure we know those cancellation properties. We talked about our cancellation properties over here, but our inverse sine on sine is only going to work as long as we're only plugging something in that's in this, in between negative pi over 2 and pi over 2. So let's make sure that what we're plugging in is that negative pi over 2 is less than or equal to pi over 6, and it is, so far so good, and that that's less than or equal to pi over 2, and it is. And so we can use the cancellation properties, spell when I'm thinking about it. We can use the cancellation property, and that's just going to give us pi over 6. So there's really, other than making sure it's in the right domain, it's within our limits, then all we have to do is just say, hey, we get that back again. What about this next one where we want to know the inverse sine of the sine of 5 pi over 6? So let's make sure it's in the acceptable range of numbers that we're allowed to use. Let's see. So yeah, negative pi over 2 is less than or equal to 5 pi over 6, but it is not less than pi over 2. So that part didn't work. So we cannot use cancellation. So what we're going to have to do instead is figure out what this gives us, and then figure out what angle gave us that. That's inside of this. So let's put in, so we want inverse sine of, so let's see if we were figuring out the sine of 5 pi over 6. So let's see, 5 pi over 6 is going to be over here, right there. 5 pi over 6 is over here. If we have our unit circle out, we can say, oh, we know what that is. If we don't, we can say, okay, well, that's just pi over 6 short of being all the way at pi. And so the sine at pi over 6 is going to be the same as that, since they're both positive. And so our sign on that one is going to be starting at 0 and going up, so we're going to be just at 1/2 there. So we're going to, now that inside part becomes 1/2, so now we want to know the angle whose sign was 1/2, but it needs to be in quadrant 1 or quadrant 4. So what quadrant are we going to need to use since we're getting a positive number? That's going to be quadrant 1. And so the angle that gave us a sign of 1/2 is going to be pi/6. So on these, we have to be careful that we're paying attention to whether our value that we're being given is inside of the acceptable numbers that we're allowed to use.